In part 1, we talked about OGAS, the Soviet Union's ambitious attempt to build a nationwide computer network. A system designed by Viktor Glushkov that could have connected factories, ministries, and economic planners across an entire superpower. Technically, it was possible. Politically, it never stood a chance. OGAS collapsed under bureaucracy, institutional resistance, and fear of decentralizing power. But while that was happening inside the Soviet Union, something very different was unfolding in the United States. To understand ARPANET, you have to understand the moment. It's the late 1950s. The Soviet Union launches Sputnik in 1957, and in Washington, that single satellite triggers panic. The US suddenly feels behind in science, technology, missile capability, everything. So in 1958, President Dwight D. Eisenhower formed ARPA, the Advanced Research Projects Agency. Its mission? Prevent technological surprise, no more being caught off guard. By the early 1960s, computers were massive, expensive machines. Universities had them, military labs had them, but they didn't talk to each other. If a researcher at UCLA wanted to use a program at Stanford, they couldn't just log in. They had to physically travel or mail magnetic tapes. It was inefficient, slow, wasteful. And ARPA was funding research at multiple institutions. They needed those computers connected. Traditional communication systems like telephone networks use circuit switching, one continuous connection from start to finish. But researchers like Paul Baran in the US and Donald Davies in the UK proposed something radical. Break messages into small pieces, send them independently, reassemble them at the destination. This concept became known as packet switching, and it was revolutionary, because if part of the network was destroyed, say in a nuclear attack, the packets could reroute themselves. The network wouldn't collapse, it would adapt. In Cold War terms, that's survivability. And survivability meant funding. On October 29, 1969, the first ARPANET message was sent. From UCLA to Stanford, they tried to type the word login. The system crashed after the first two letters, so the first message ever sent across ARPANET was LO. Not exactly poetic, but historic. By the end of 1969, 4 nodes were connected: UCLA, Stanford, UC Santa Barbara, and University of Utah. And it kept growing. Here's the critical difference between OGAS and ARPANET. OGAS threatened centralized control in a planned economy. ARPANET fit perfectly inside the American system. It wasn't trying to replace government hierarchy. It was funded by the military, built by universities, contracted to private companies like BBN. It aligned with the Cold War defense priorities, academic research culture, decentralized innovation. In other words, ARPANET didn't fight the system. It worked with it. In 1971, something unexpected happened. Email was invented by Ray Tomlinson. And suddenly, researchers weren't just sharing computing resources. They were talking. By 1973, email accounted for 75% of ARPANET traffic. The network stopped being just a military experiment. It became a communication platform. That shift changed everything. ARPANET was powerful, but it was still just one network. The real breakthrough came in the 1970s with TCP/IP, developed by Vint Cerf and Bob Kahn. Instead of building one giant network, TCP/IP allowed multiple independent networks to connect. A network of networks. That's where the word internet comes from. On January 1st, 1983, ARPANET officially switched to TCP/IP. That date is often called the real birth of the modern internet. It wasn't just technology, it was timing. It had Cold War urgency, stable federal funding, academic collaboration, open technical standards, and a culture that encouraged experimentation. OGAS tried to optimize a planned economy. ARPANET tried to connect researchers. One threatened power structures. The other strengthened them. And that difference shaped history. In 1990, ARPANET was officially decommissioned. By then, it didn't matter. The internet had already escaped the lab. The World Wide Web would arrive shortly after, in 1991. And the rest you're living in it. Every message you send, every video you stream, every site you visit, it traces back to a Cold War research project designed to survive nuclear war. When we look back at OGAS and ARPANET side by side, something becomes clear. Technology alone doesn't decide the future. Politics does. Institutions do. Culture does. The Soviet Union imagined a network to manage the economy. The United States built one to survive war. Only one evolved into the internet we know today. Both were visionary. Both were born from Cold War urgency. But only one was allowed to grow, adapt, and escape the system that created it. Make sure you're following for more such interesting tech history.